In this video we're going to talk about integration by substitution, and knowing that this is review, I'm going to just kind of give you a rundown and a review. Remember, we're always trying to pick a function u to be u that's derivative also appears in the function, so that we can kind of get rid of our quote-unquote problem. So in this first example, you know, I've got a function divided by another function. I don't have a quotient rule for integrals, so I'm looking to do substitution. That's my first goal. And you look at x to the fourth plus 1 as the lower function. The derivative of that would be 4x cubed, which is awfully close to the numerator, and I could do some adjustment to make it the numerator. So I'm going to make u equal to x to the fourth plus 1. So then du is 4x cubed dx. And you notice right here I have a dx I want to replace, and up here of course I have an x cubed. So if I were to divide both sides by 4 and have 1/4 du, I could replace the entire x cubed dx with a 1/4 du. So my integral would become 1 divided by u multiplied by 1/4 du. And I always like to put my constant multipliers out front. So it's just 1/4 the integral of 1 over u du, which of course is natural log. So we have 1/4 natural log of u plus c, and we then just plug u back in to put it back in terms of x. So natural log of x to the fourth plus 1 plus a constant. Looking down at the second one, we've got a 2x squared, we've got a cosine x cubed, and again, we do have a product rule for integrals, but it's a lot easier to do substitution. So if I were to make u x cubed, the derivative would be 3x squared. That's really close to this. And in fact, you know how I would like to just pull that 2 out front like that. It's really close. Notice why it can't be the other way. You can't make ux squared because du doesn't appear. There's no 2x. So we're going to make u x cubed. So du is 3x squared dx. Okay, I'm going to divide that 3 out. I'm going to put a 1/3 over here. And now I can replace the x squared dx. I can replace that with a 1/3 du. So I already had a 2 outside my integral. I'm going to put that there. I'm going to have the cosine of u times 1/3 du. And then I'm going to pull that 1/3 out front as well. So that means I'll have a 2/3 out front. The antiderivative of cosine is sine, so I have 2/3 sine of u plus a constant, and then I just plug what u is equal to back in. Like that. So we're really looking at products and quotients, and you can see down here, that we've got sine, we've got cosine x. I would usually make u the denominator, with very few exceptions. If we make u equal to cosine of x plus 1, then du would be negative sine x dx. But I could just change the sign of my du, and now I can replace that whole thing with a negative du. So my integral will become 1 over u times negative du, and I'll just bring the negative out front. I'm not going to finish that one because it's really similar to the first one. So let me go on to the next. Here, let's just set up again what u and du would be, and we can take it from there. In cases with e, almost always u will be the exponent. du is 2 dx. Of course, we don't have a 2 dx, we only have a dx, so we divide by 2. So my integral would become, and let me put that 1/2 up front right away. E to the u du. And the antiderivative, of course, of e to the u is e to the u, so the final answer would just be that. Okay, here, a little bit ugly, I guess, but remember that the derivative of tangent is secant squared. So if I made u tangent, then du would be secant squared of x dx. So let me just show you. I'd be able to replace all of this stuff in blue with just a du. So my integral, if I pull that 3 out front like I always do, I'd have the square root of u times du. And again, it's because that's all that's left. I have the square root of u because I replaced tangent with u, and everything else got replaced by a du. And I'm going to let you finish that one, or I would rely on the fact you could finish that. Okay, this one. The temptation is to say, well, u has got to be x squared. It does not work to have u be the numerator. So it seems like there's nothing we can do. Well, in fact, there is. What we need to do first, and this happens pretty much any time the numerator power is bigger. Or maybe I should even rephrase that. The numerator power is not smaller than the denominator. We have to polynomial divide first. So I'm going to take x squared plus 3 and divide it by x minus 1. Easiest way to do this, of course, is to create some room. So I'm going to have 0x plus 3. So now you say, well, x multiplied by what is x squared? That's the first step. Well, x times x is x squared. Then we take this number and we just multiply it by both terms. X times x is x squared, and we just write that just below. X times negative 1 is negative 1x. And we subtract. Now the whole purpose of this was that so these first terms would cancel out. But now you need to say, well, 0 minus negative 1x is 1x. And the 3 just drops down. We now repeat, same process. X multiplied by what is 1x? Positive 1. So we put a positive 1 up here. And we take our positive 1 and just multiply it by both terms. 1 times x is 1x. 1 times negative 1 is negative 1. We subtract. These first terms cancel out. They should every time. That's our goal. And 3 minus negative 1 is 4. Now you'll notice that x doesn't go into 4. So we're done. This is our remainder. So we rewrite our original function, x squared plus 3 over x minus 1, can be rewritten as x plus 1 plus our fractional kind of remainder, 4 over x minus 1. So our answer was x plus 1, like that. Our remainder was 4, and it's over the divisor, the denominator. Well, now, think about if these two things are equivalent. If x squared plus 3 over x minus 1 is equivalent to this, that must mean they have the same integral. Well, now, it's a very easy integral to do. It's going to be 1/2 x squared plus x plus 4 times the natural log of x minus 1 plus c. And that's it. So this this ends up being a pretty nice, easy integral once you do that polynomial division. And just kind of thinking about how this finishes off, this x plus 1 over, or x plus 1 plus 4 times x minus 1. If you got a common denominator, you multiplied this whole thing by x minus 1, you'd get, on top here, you'd get x squared minus 1 plus 4, so that's x squared plus 3 over x minus 1. So you see, it really is just breaking it apart to not have a common denominator anymore. That's all we did by doing division.